Hi guys, we are going to continue on with chapter 10, well the exponential part of chapter 10. So today we're going to talk about exponential growth and compounding interest. Exponential growth is what we talked about a little bit last week, where the graph is going up very quickly from left to right. This is also what we were trying to avoid with the coronavirus curve. So exponential growth is something that grows very quickly. Compounding interest is a form of exponential growth, so these go together very well, but that's just got one little extra component that the regular exponential growth doesn't have. These each have their own formula that we're going to give you and tell you exactly what each part means, and then on your assignment you use each formula in the right place. So exponential growth, you take the initial amount, okay, which in the formula is the C value, and it increases by the same percentage written in the rate, okay, which is the orange one, over a given period of time, t, which is your exponent. So the whole thing with exponential functions that we talked about last week was that they increase or decrease by a percentage. Okay, so that's what's going to make these exponential. So as opposed to saying like, I have $50 and I save $2 every day. The fact that you save $2 every day is not a percentage. That's not a multiple. That's a steady increase, which would make a line. In order for it to be exponential, it either has to be going up by a multiplier. So like I double how much money I have every day. Doubling, multiplying everything by 2 makes it exponential. Or a percentage, so it's increasing by 10% every year. The percentage also makes it exponential, okay? In this formula, this C value is your initial amount, so however much you start with, okay? That's how much you start with. The 1 is always there. This addition sign is because it is growth, okay? On Wednesday, we're going to do exponential decay when it's going down, so that'll change. But the addition sign is because it is growing. This rate is going to be a percentage, and you are going to write it as a decimal. Okay, and we'll talk about that when we go over it. And then T is time, which is pretty self-explanatory. How long is it growing for? Okay, so it's all color-coded in here for you with the green, the orange, and the blue. And then this is exactly what all of that means. Okay, so let's look at an example. Exponential growth in the year 2000. So exponential growth, it's telling you exactly what formula to use, which is why we write this formula down. Okay, in 2000, Mexico had a population of 100,350,000 and a growth rate of 1.7% per year. Predict what the population was in 2012. Okay, Ms. Bowerman made these notes for you, and she even put these things in with color coding, which is really nice of her. So C is the initial amount. So how much did Mexico have when you started counting? Okay, that is the 100,350,000. That's your initial amount. That's how much they had at the beginning of all of this. Okay, a growth rate. So the fact that it's growing tells you have to have an addition sign here, which we already knew. Now, here's the part you need to pay attention to for sure. This 1.7%, we're not going to put the percent sign in our formula. So we are going to make this a decimal. So we are going to take this decimal place and move it 2 places to the left. So that is 0.017. So you're using the decimal as opposed to the number with the percent sign behind it. If you don't know how to do that in your calculator, if you put 1.7 and then the percent sign and hit enter, it'll give you that decimal. So 1.7% enter will give you 0.017, which is what we want as our rate. Okay? T is time. Be careful with this as well. So the blue number right here is 2012. I am not going to plug 2012 directly in for time because I have not been counting for 2012 years. I didn't start in year 0. I started in the year 2000. So I have to subtract 2000 from 2012 to figure out how long I have been growing, which is going to obviously be 12 years. So just be careful with the growth, with the rate and the time. They're not always exactly the number that was handed to you, okay? However, once you know all of those things, then you simply plug them in. So my C was 100,000 or 100,350,000. Then I put a parenthesis, and then I put 1 plus because I'm growing. My growth rate was 0.017. And my time, which is my exponent, was 12. Once you have all of that written down, you put it in your calculator exactly how it is written. So you put the 100,350,000, then you put your parenthesis, then your 1 plus 0.017, close parentheses, and then your little caret to the 12th, okay? When you do that, your calculator will spit out this crazy number for you. So 122,848,204.1. Now be careful. You have to know what you're talking about. We're talking about people, population. You cannot have a fraction of a person, so you're just going to get rid of this 0.1. You don't round people up. You just leave it exactly how it is, and then you tell me what you found. So that's how many people there were in 2012. Remember, if I give you words, you give me words. So you go ahead and you put those in, and then you're done. Okay? Hopefully that's good. On your homework, there are 2 questions where you are using the exponential growth formula, which is that one, and the formula is up at the top, and then you just plug the numbers in accordingly and then answer the questions, okay? The other formula is similar, it just has one extra variable in it. So it is compounding interest. So if you invest your money in the bank and they pay you interest for that, okay, then you get your interest a certain number of times a year. It's the same thing if you borrow money, they charge you interest a certain number of times a year, and it would be calculated the same way. Okay, so this is extremely similar to the one we just did. The number in front, the green number, is your initial amount, just like before. It's just when you're talking about money, it's called the principal, which is why they put it as a P. Okay, so when you're talking about money, if you're investing or you're borrowing money, the initial amount is called the principal, which is why it's a P. And then 1 plus, because you're adding your interest to whatever you invested. R is still your rate as a decimal, just like before. T is still your time, just like before. The only new component is the N. Okay, it's used twice in the formula, but it's the same number each time. N is the number of times a year the money is compounded, the interest is compounded. Okay, so number of times a year interest is compounded. So you know you need to use this formula if you anywhere in the question see the word compounded. The second you see the word compounded, the word after that is the one that tells you how many times a year the interest is compounded. So if it's compounded quarterly, if something is compounded quarterly, how many times a year do you think that is? Quarter is 4. Okay, so your N would be 4 if it says quarterly. If it is compounded monthly, how many months are in a year? Something is compounded monthly, then there are 12 months in a year, so your N would be 12. If it's compounded, this one's a tricky one, semi-annually, okay, semi-annually is What's a semicircle? Semicircle is a half circle, so how many half circles does it take to make a whole? 2. So semi-annually is twice a year. Annually, which is the one we're going to do, is just once a year. So it just depends on what the word is, what your N is, okay? And then T is still time. So let's look at this. When May was born, her grandparents invested $1,000 at a fixed rate savings account at a rate of 7% compounded annually. The money will go to May when she turns 18. How much will she receive? So the word compounded is in here. If it's compounded, then you have to use this longer formula. Okay, again, on your assignment, it even says to use this formula, so it's pretty straightforward. Once you know what formula you have to use, you know that these things on the sides are the letters or the variables that you need to identify before you can use it. P is your principal, or how much you start with. So they initially invest $1,000. So P is 1,000. The rate, the percentage, is your R. Again, you don't want to use the percent sign, so you can put in your calculator 7%, hit enter, or you can simply move the decimal place 2 places to the left and you get 0.07. So 0.07 is your rate. N is how many times a year it is compounded. So be careful. You've already identified the word compounded to know you needed to use the longer formula. The word that comes after compounded tells you how many times a year. So compounded annually. Annually is just one time a year. So since it's annually, your N is 1. Finally, time. It says when she turns 18, and they did it when she was born, so that actually is 18 years. If it was started when she was 18, and started when she was born and it goes until she's 18, then time is 18 years. Okay, once you know all of it, you plug it in. So my P was 1,000. 1 plus, my rate was 7%, which was 0.07. My N compounded one time a year. And then my exponent is my N was 1 and my time was 18. And since I have 2 variables up at the top, they're going to get multiplied together. Okay? Now, since this one is annually, it's easier to do, but you should start with your exponent before you put it in your calculator. You need to know what that number is because you can't do a caret and then put 2 numbers next to each other. So the 1,000 stays the same. 1 plus 0.07 divided by 1. And then up top, 1 times 18 is just 18. You just have to do this multiplication regardless of what it is to get this number before you can put it in your calculator. If you put this in your calculator all at once, that's fine. Just make sure that you put this in an extra set of parentheses so that you can do that division beforehand. Okay? Once you do that, you get 3,379.93. And then you say, okay, I was talking about money, so 2 decimal places is correct. This is money, dollars, when she is how old? 18. Okay, so that's how much money she'll have when she is 18 because they invested $1,000 when she was born. Okay? All right, I think on your homework, I tell you, or Miss Bowerman tells you, exactly how many times it's compounded a year. So it says compounded quarterly, but then in parentheses it says 4 times a year. So that means that your N is 4. And then the second one says compounded monthly, which is 12 times a year, so your N is 12. Okay, so that part's pretty straightforward. Just make sure you're putting it in your calculator correctly. And if you need any help, just let us know. It's just the exponential growth and interest worksheet in your homework folder. Bye, guys.